thank you for having me. It's been part of the institute, so I didn't really have a choice to include me. I'm going to present the project that we've been working on toward assessing chemical exposures from consumer purchases. More specifically, we're going to use data from the my purchase cohort. So today's program, what are we going to be talking about? First one being why are chemical exposures so interesting? I mean, Steve made a good point as why they were interesting, but and then second, how can we define them? What does our data look like, and how can it be used? So first, a little background. So in the EU, there's been a lot of focus on potential harmful effects coming from chemistry and consumer chemistry. Second, we in the EU have this database called REACH, stands for Registration, Evaluation, Authorization, and Restriction of Chemicals. And that's a database that contains comprehensive mapping of chemicals that are commonly used in the EU. And third, individual exposure profiles are typically pretty hard to obtain. The aim of what we are doing is to obtain chemical exposure profiles through these consumer data that we have, and then assess chemical exposure profiles that's associated with self-reported health outcomes. And just to disclaimer, when we made this kind of cohort, it was meant that we were able to use register-based data, so connected to all the Danish registers, but those have not become available as of yet. So right now we're only using the self-reported ones that people enter when they sign up the project. What is chemical exposure? So chemical products is a broad category that encompasses a wide range of products. We will be looking at exposures coming from the following type of project. Products falling, that's cleaning products, cosmetic products, textile, chemicals, but we will also be considering tobacco and other nicotine products and indoor pollutants when we focus on indoor cleaning. There obviously exist other types of chemical exposures, such as plastic, polymers, chemical additives in food. Could be paints, coatings, and stuff, but those are not considered in our project as of yet, but maybe the future. Where does our data come from? We have the My Purchase cohort, where we have 466 participants that agreed to share data that could be used in this product about chemical use. That adds up to around 211,000 receipts, spanning all the way down, all the way back to 2014 and up until today. And that summarizes to 131,000 unique products. We have Frida, which is like, we have Frida and our version of Frida, which has 1,353 genetic food labels and non-food labels, and we use regular like fragrance to identify tobacco and nicotine products and candles in this cohort. Then we have Camillum, which I'll talk about later, but it has 23,000 cosmetic products, and those products are classified based on a suspicion of harmfulness. And we match these two on the barcode, and we match these two on product name. When we do that, we end up with 436 participants, but 30 was not included since they didn't have any data. And we identified about more than 50,000 purchases and 3,500 unique chemical products. So Camillum, what is Camillum? Camillum is a free Danish app that people can use to scan additional chemical products from retailers. And gain information about potentially problematic chemicals. The data set again contains 3,000 chemicals. It also includes names of the product groups of what kind of product is this. Chemical compounds, all the individual chemical ingredient list, and this classification in 3 levels. The first one being A, which states that it's free of any kind of problematic substances. B, saying that it's still free of any kind of problematic substances, but it might contain like perfume that could be irritating to some people, or substances that can be harmful for the environment. And C, where it contains some kind of problematic ingredient, such as maybe substances that are suspected to be hormone disruptive. So just to give an example of what it would look like, we have Colgate toothpaste. That's a soap and hygiene product. It has these ingredients and a lot more. I didn't want to do it everyone, and it's classified as pink. Important to notice that this kind of data set does not contain any weight information of the products, not at the product level, but also not at the chemical level. So we don't know if it's only like a very limited amount of the chemical. And then we have our cohort. Yes, we have all these purchases. We can see the distribution of product groups here, and I've only included it really just to tell that the kind of chemical products that we have are kind of wide. We have all bunch of different chemical products. And then also we have a table with some data. And again, we are supposed to have more demographic variables, but right now we only have the age and the sex and the color type that have been part of this. We see as every single one here also saw the participation rate are high among middle to older age women. But we also note that we have quite a long time of enrollment. We have more than half of the participants have been part of this study for more than 5 years. So that's a lot of data. If we move onwards to look at some chemistry, we see that participants have a median exposure of 50 chemicals in this period, which add up to around 210 unique chemicals exposed. We see that 15% of the products that we have, that people purchase, are suspected to be endocrine disrupting according to REACH. And 26 of those products are also labeled C+ according to Copenhagen. So products that could be harmful. And we look at the rest, and we see we identify 41 participants in our cohort that are either present or previous historical smokers, but that's obviously only the time period of the study. And we also see we have quite a limited amount of data for nicotine users and candle purchasers. So I claim that there's a great variation in the individual chemical exposure profiles, and this kind of chemical exposure profile could have biological effect on health. To kind of illustrate that point, we make a plot where we, on the x-axis, have the participants, and the y-axis we have the product groups, and then we plot the fraction of purchases made by each participant within the product category. And the point of this is to see we have some product groups, which is, I don't know how clear it is, but some product groups that are more like money, and then we have certain product groups that are more concentrated in the sense that there's only a few people that buy that kind of product. Nicotine users that have example. And we like to think of this kind of figure as like a chemical exposure fingerprint, where every single one has like a very unique combination of exposure. It's a very exposure profile is very, very complex, and many of the details can contribute to the poor health when it comes to these profiles. The first one being income exposure. There's a very difference between being exposed to a certain product like a chemical once or twice, or having been exposed to it for multiple years. Doses is an obvious one. Combination of exposure is also at least interesting. And as well as using types, there's a difference between putting certain lotion on your skin compared to inhaling it or stuff. So, but before we start using all of those things, we just plotted the average monthly chemical products purchase compared, the average monthly chemical product purchase, where we compared people that have reported some kind of disease in these disease groups, and then we compared to people that are healthy, or at least people that did not report any kind of diseases. And then we stratified according to the Kimmel hazard classification. Here we see that the majority they buy the same as compared to healthy participants. The only significant thing is the people that has reported an atopic disease. It looks like they have like a slightly significant difference where they typically buy more A-classified products, which could just be a result of people being more aware of not buying chemical products that could be irritating. Then we have the same kind of plot where we again have people with these disease types, but now here we classify the products. We identify all the chemicals in each product, and then those chemicals if they have a hazard associated with them according to the database breach that I talked about earlier, then we classify the product as these ones. And then we plot the same monthly chemical product purchase. This figure doesn't really show any significance, but it was the due diligence. But right now we have not really considered the time aspects of all these exposures that we have, because each participant we can consider them as having like many of these small measurements over time, but if I find 10 products, and then we have data spanning more than 5 years. But during this period, people's purchase patterns can change a lot, and ignoring it could just lead to very wrong conclusions. So to illustrate this kind of idea, we plotted the cumulative purchases of cigarettes for the 41 participants that we identified as smokers during the time of the study. And looking at this, we can kind of identify certain behavioral changes. So it could be, obviously periods with high versus low consumption periods. People that might have stopped altogether smoking. It could be very recent behavior versus historical behavior that would become obvious factor in determining health risks. But it could also be something as simple that people might change the location where they buy cigarettes or other products, so we might catch them in a certain period, but then they swap and then we don't catch them. How do we model some or all of these aspects of data? And the question to that is that it's validation. We are in the process, but it's kind of, we don't really have all the results now. This is still, we haven't published anything and stuff like that, so it's still work in progress. But the future aspects of what we would like to do with this kind of data, our data type is very suitable for something like specific machine learning or deep learning methods. Since we have a lot of data on an individual level, so it could be very interesting to employ like certain neural networks, long-term short-term memory networks, convolutional neural networks, something third. We are not experts in this kind of field, so if anyone have any suggestions of what could be done on this, that would be very useful. The unfortunate part is, despite we have this very detailed data on an individual or household level, we are currently limited in our sample size, which makes neural networks suboptimal. This will hopefully change with time as the solution gain more popularity among the populations. So what we are currently doing right now is that we are more working on this data summarization approach, where we kind of take each of the exposures that we're interested in. So that could be tobacco, but that could be certain chemical products that has like a specific focus. And then we try and summarize that into key variables that will hopefully catch these kind of time series behaviors that we see in data, such in a way that we can reduce dimensionality, and so we can use like machine learning and deep learning method across these different exposures simultaneously, because we don't want to look at smoking isolated. We want to kind of add all the data all together and then model it simultaneously. But we haven't done that yet. So don't skip that. And then quickly just the conclusion of what we I'm the work of doing. We're able to link this my purpose cohort, which I haven't mentioned it. But yes, to online chemistry databases, in this case, we look and reach, and this allows for identification of chemical products, and as a result, with the ability to estimate these kind of chemical exposure profiles. And then these exposure profiles are used to investigate association and self-reporting health outcomes now. And they will hopefully serve as like the foundation for the future when we are able to use these more sophisticated methods as data.